Hey guys, this is Kevin Budushevsky, and this is effective renal plasma flow. So effective renal plasma flow, or ERPF, is the amount of plasma flowing through the kidneys per unit time, and can be estimated using the para-aminohippuric acid clearance, or PAH. PAH is freely filtered by the glomerulus and actively secreted by the proximal convoluted tubule. This means that almost all of the PAH that enters the kidney will ultimately be excreted. PAH clearance can be estimated using ERPF. This will be approximately equal to the overall amount of plasma that enters the kidneys at any point in time. Renal blood flow, on the other hand, can be calculated by dividing the renal plasma flow by 1 minus hematocrit. So let's take a second to understand why you would do this. Remember that the blood has two major components. What are they? Well, that would be the red blood cells as well as the plasma. Hematocrit is defined as the percent of volume taken up by red blood cells. So this means that 1 minus hematocrit represents the percent of volume taken up by plasma, because we're subtracting the red blood cells. Dividing renal plasma flow by 1 minus hematocrit allows us to calculate the total renal blood flow, including both plasma and cell volume. Clinically, it's important to note that ERPF underestimates the true renal plasma flow by about 10%. So here's a question related to the blood flow for you. How much of the resting cardiac output do the kidneys receive? Well, the kidneys receive about 25% of the resting cardiac output. This is typically about 1.2 liters per minute. Alright, time for a flash quiz. What's the formula for estimating renal blood flow if renal plasma flow is known? Answer: renal blood flow equals renal plasma flow divided by 1 minus hematocrit. Recall that the 1 minus hematocrit in this case equals the plasma volume. Normally, renal blood flow is about double the RPF.